All right. So for this problem, ladies and gentlemen, if you remember when they're asking us to solve linear systems, all right? Remember now, rather than just solving for one variable, Ricardo, what we have is we have two equations and we need to solve for two variables. So just make sure for however many variables you have, that's how many equations you have. So there's actually three methods we worked on this. We worked on solving linear systems by graphing. You could use a substitution, or you could use elimination. And there's kind of three important ways that kind of helped us to do it, what we're kind of depending on. However, one thing, if we had a variable that was already solved, the easier algebraic method would be, does anybody remember? Substitution, right? Because what you know is, oh, y equals x plus 1. So we can now substitute in what y equals into the other equation. So I could say 3x plus 2 times x plus 1 equals 22. And the reason why this is helpful, because now what I did is I created an equation that only has one variable. And we know how to solve an equation with one variable. So the first thing is we simplify. Then, so we get 5x plus 2 equals 22. Now going back to our days in Algebra 1, we can use inverse operations. Divide by 5. So therefore, you could say x equals 4. So now we know that x equals 4. So to find y, I go back to one of my equations. It doesn't matter which equation you choose. However, you'd probably be easiest to choose the equation that's already solved for the variable you're looking for, because then you can just plug in 4 into that equation. So y equals 5. And that is your linear system. Now, if you want to check that, you can plug in y in for 5 and 4 in for x into both of those equations, and you'll see you will create an equivalent equation. OK? Good job. Gracias. Thank you.